Today I'm going to be discussing how to determine concavity and find points of inflection for a function. Before I start, I'm going to define what a point of inflection is. A point of inflection is a point in a graph or a function where it switches concavities. A function's concavity refers to whether it opens upwards or downwards. So something that is concave up may look something like this. And something that is concave down might look something like this. Now I'm going to show you guys how to calculate points of a concavity and points of inflection. For this example, I'm going to be using the following function. F of x is equal to x e to the x. Now, before I go any further, I'm going to say that when finding points of inflection and determining concavity, we need to use the second derivative of the function. So as I mentioned in the previous video, it is very important to be vigilant and pay attention to what they give you, because sometimes they might give you the first derivative or the second derivative, and it could mess up your results. So you need to pay close attention to what they give you. In this case, they give us the original function. So now we need to apply a derivative twice. So I'm going to do this, and for f prime of x, I'm going to use the product rule to get the following. I'm going to get e to the x plus x e to the x for the first derivative. Now I'm going to do the derivative one more time, and I'm going to get that the double derivative, or the second derivative, is equal to e to the x plus e to the x plus x e to the x. Now my next step is to combine like terms and then set the function equal to 0. So once I do that, I'm going to get the following. 0 is equal to 2 to the x plus x e to the x. Before I go any further, I notice that they have a common factor of e to the x. That means that I can factor this out to make it easier to find the zeros. So I'm going to rewrite this as e to the x times 2 plus x is equal to 0. Now I can determine that my 0 is negative 2. So now my next step is to create a number line using this point. So I'm going to do something like that, and I'm going to draw a negative 2 here. So now I need to plug in points to this function right here before negative 2 and after negative 2 to determine concavities. So I'm going to start by plugging in a point before negative 2, and I'm going to just choose to do negative 3. So I'll put a negative 3, and then for the point after negative 2, I'm going to use 1. So when I plug in a negative 3 here, I get that negative 3 plus 2 is equal to negative 1. And that negative 1 is going to be multiplied times e to the negative 3. So this is going to give me a negative number, which means that the points before negative 2 are negative. Now when I plug in a 1 to this equation, it's going to give me a positive number, because 3 times a positive e gives me a positive number. So the points after negative 2 are positive. So now from the data that we've collected, we can determine when the function is concave down and when it is concave up. So the function is concave down when the x is less than negative 2. And the function is concave up when x is greater than negative 2, as shown by the positive values here and the negative values over here. Now, because at the point negative 2, the function switches from being concave down to concave up, I can confirm that there is a point of inflection when x is equal to negative 2. Now, to find the actual point with its y value, I would need to plug in this negative 2 to the original function, which is what I'm going to do right now. So once you do that, you're going to get negative 2 times e to the negative 2 power for the y value. So once I simplify this, I'm going to get that my point of inflection is negative 2 comma negative 2 over e squared. And this would be my point of inflection right here. And these right here would be when the function is concave down and when it is concave up. And that's all there is to it.